Assalamualaikum warahmatullahi wabarakatuh. My name is Zulfikar Zafir bin Abdul Qadir. Today our presentation I will explain about spring.
And my name is Muhammad Fida Shafiq bin Muhammad Nazim.
So guys, first our presentation is spring. So what is spring? Spring is a bendy piece of metal that can stretch or squish and then go back to its original shape. So it's used to store energy and release it when need, like pen, cars or trampolines. Okay, spring follow a rule called Hooke's law. F equal kx is mean where F is force, K is stiffness, and X is how it's strength. Okay, material from spring is carbon steel, stainless steel, alloy steel. Thank you.
Is the opposite, the extension or tension spring. This is also a helical coil but with hooks or loops on both ends. Its job is to resist stretching or a pull. Think about what needs to be put back into place. That is why we use them in trampolines, garage doors and screen doors. The third type is the torsion spring. This is a coiled spring that twists rather than stretches or compresses. It is designed to store rotational energy. These are essential for mechanisms that need a snapping or rotating force such as clothespins, mousetraps, and the latching mechanisms in car doors. Now we move away from the chord variety and look at the leaf spring. This one is a little different. It's made of layers of metal strips that's bound together. Its primary function is to support heavy loads and absorb shock. The leaf spring is a workhorse in the transportation industry, common in the suspension systems of heavy trucks and trains. Our fifth spring is the intriguing spiral or clock spring. As the name suggests, it's a flat strip of metal wound in a tight spiral shape. Its purpose is to store and release rotational energy gradually. This mechanism is what makes old-fashioned things tick. They are used in clocks and watches, and a modern use is in seatbelt retractors to keep the seatbelt taut. Let's talk about high carbon steel. This is a very common and economical choice for many spring applications. You'll often find this specified as music wire, which is known for its excellent tensile strength and fatigue life, and hard drawn wire, another general purpose spring wire. High carbon steel offers a compelling combination of high strength and hardness, good elasticity, and perhaps most importantly, it is relatively inexpensive. This makes it ideal for a vast range of everyday springs where cost is a factor. Moving on, we have alloy steel. This category enhances the properties of carbon steel by adding other elements. Common examples include chrome vanadium and chrome silicon. The addition of chromium and vanadium or silicon significantly improves performance. Alloy steels are valued for their excellent fatigue resistance, meaning they can withstand many cycles of loading and unloading without breaking. Crucially, they can withstand high stresses and temperatures, making them suitable for more demanding environments than standard high carbon steel. Next, let's consider the stainless steel. The most common types used for springs are types 302, 304, and 316. These are austenitic stainless steels known for their corrosion resistance. The standout feature of stainless steel is its corrosion resistance. This makes it indispensable in environments where moisture, chemicals, or other corrosive agents are present. Beyond that, it also provides good strength and toughness. ensuring reliable performance even in challenging conditions. Finally, we have nickel-based alloys, which represent the high performance end of spring materials. Well-known examples include Inconel and Monel. These are super alloys designed for extreme conditions. And nickel-based alloys are chosen when other materials simply won't suffice. Their key properties include high strength at elevated temperatures, making them perfect for applications in engines or industrial furnaces. Furthermore, they offer excellent corrosion resistance, often surpassing stainless steel in very aggressive chemical environments.
So the next part is application for spring. So spring are all over the place. We use them in vehicle and machine. For example, is shock absorbers to make the ride less bumpy, and a clutch and brake to help car stop and change gear. Next, for daily life, usually we use to pen to click the part pen, and materials to make them comfy and bouncy, and toys like wing up toys, and door locks to make the crash snap back into place. So for electronic, usually battery contact to push the battery against the metal terminal and switch to turn things on and off. Right? Basically anything that need to be pushed, pulled, hair tied, or allowed to bounce back, probably as a spring in it. First to Okay guys, after we discuss about application spring, we must to check spring inspection to make sure a spring is made well and will work properly. We check in three main ways. First one, visual inspection. So we check for defect. We look only closely at the spring surface to find any scratches or dents. These small flaws can make the spring weak and cause it to break. So check the shape. We make sure the coils, the loop of the spring evenly spaced and look uniform. The spring should be straight, not crooked. And last, check the ends. We look at the top and bottom of the spring to make sure they are shaped correctly. If the ends are supposed to be flat, we make sure they are. So next, for dimension inspection. So basic measurement, we use tools like calipers to measure important things like how thick the wire is and how wide the spring is. Next, advanced measurement. For every precise checks, we use special machines. Some use a probe that touch the spring all over to make sure its shape and size are perfect. Other use cameras and computer to measure it without even touching it. This makes sure the spring matches the original design easily. And last one, mechanical testing. So stiffness test, we test how spring or stiff it is. We apply a specific amount of force and measure how much the spring squeeze and stretch. Okay. Load test, we find out how well it can handle. We squeeze or stretch it to its limit to see how strong it before it gets permanently bends or break. Okay, understand? And next, last one, durability test. So we check to see if it was a long time. A machine will squeeze and release the spring over and over, sometimes millions of times, to simulate real work, use and make sure it won't get tight and fail. Okay.
I'm gonna talk about the characteristic of a spring. The first one is elasticity. Elasticity is arguably the most important property of a spring. It's the ability of the spring to return to its original shape after being stretched or compressed. Without elasticity, a spring becomes useless junk metal. Next one is the tensile strength. Tensile strength defines the limit of the material. It measures the maximum stress a spring material can handle while being stretched before it breaks. Fatigue strength is crucial for longevity. It is the ability to withstand repeated loading and unloading without failure. This is absolutely essential for springs used in a system that cycle constantly, like engines or suspension system. The next one is stiffness. Stiffness is what gives a spring its feel. It simply measures how resistant the spring is to deformation. A high stiffness spring is hard to push, while a low stiffness spring is easy to push. Ductility relates to the material toughness. It's the ability of the material to deform without breaking. This is particularly important for springs that under deflections or significant bending and stretching. And finally, we have the corrosion resistance. The corrosion resistance determines a spring's working lifespan. This is important for spring exposed to moisture, chemicals, or outdoor environments.
The last part is how we testing the spring. So look at the picture. So first one is compression test, squeezing. So we squeeze or crush the object from the top and bottom to see how much of a crushing force it can handle before it's bend, back, or break. So think of it like this, pressing down on a spring to see how much it squeeze. Next, for tension test. So we pull the object from the board ends trying to stretch its part to find out how much the spring pulling force it can take before it's permanently stretches or snap. The different mechanisms show this can be done with a little force load or a hug amount of force high loud. So a game of tug of war to see when the rope will break. The last one is torsion test. We hold the object and twist to see how much twisting force in can resist before it get permanently twist or break. So bringing out away. That's for my thank you.
In conclusion, springs are essential mechanical components designed to store and release energy, absorb shock, maintain force between contacting surfaces. Their performance depends on factors such as material selection, design, and manufacturing quality. Springs are valued for their elasticity, durability, and reliability, making them vital in various applications, from automobiles to electronics and everyday tools. By understanding their types, materials, and characteristics, can choose the right spring to ensure efficient, safe, and long-lasting mechanism.